guys. Let me just try my best to hang with me here to explain some stuff. We're going to get real heavy with zeta radiation and gamma function, or zeta function and gamma function, to this here in a minute. And I'm going to show you something. I want to take a special moment out of Strip Steer here saying something while going through the book and doing all of this with gold solution to do electrolysis with gold. He's going to do this whole process, gets a decent yield out of there. We got some thermodynamic stuff, and this is usually pretty heavy for people about what it is we're talking about. Well, we're talking about it right here. There's going to be some stuff about the zeta function, their electrolysis of gold, and gamma function. That I am one of the best, that there's a gamma radiation off of this. It's not quite heat radiation. It's not quite radioactive demon core radiation where you would die, but you could see standing next to Strip Steer without Street Tip here without the ability to know the function or break down the parts, or at least the majority of that timeline. So, which we'll get into. It doesn't say the distance of how far the anode and the cathode have to be away from this. You might have to do a little bit of trial and error. And the fact that you actually had an IH reaction like that is that gamma radiation, it's a form of it, or at least the identifier for it, in a zeta function. Okay, so let's see if we can find it real quick. Let's see where she is. Yeah, here we go. And so he's telling you what this should yield out in the electrolysis process. Very good. A few years ago, certainly has improved it over the process, but not by much. Most of this, all the same, you're going to get out of him.
Okay, even though these were very elementary calculations for the electrolyte concentration, I had to call my good friend, Dr. Paul Young, math professor at the College of Charleston.
And I bet you he could run these numbers. And because you're at college, usually you're pretty better about throwing down that calculation or double checking the process and the numbers themselves that it was all done to help you do it. So, in a way, Street is actually emitting a gamma radiation, a gamma prime radiation, which is to say like a prime student, not a gravity. He's talking about Young, which I agree with if they're using the Riemann zeta function, or gamma radiation. Those are nuclear, makes this a form of nuclear reactor, like Iron Star or heat death stuff. You have to have that. The drunkard walk problem, you violate the second law of thermodynamics. And you can't, it would just be all stable. It would all be homogenized, which shows proof that it is not. And without that, the miracle of life and any of this stuff, just not going to happen. So, that's what he said. Strip Steer. Guy does gold plating, obviously making pretty good in life some way. Let's see, where did it go? There we go. Hang with me here. Ah, there she is. Now listen to this guy talk. It's a hard thing to follow. Kind of like watching astrophysics or something like that. If you don't know quark states, then you're not going to get a magnetar quake could identify LEGO as that, but Navy Astrology Center still identifies it as a neutron star bandwidth, not a quark star. But it doesn't, the outlier of very stable bandwidths of neutron stars, so it's quirky. And that can range magnetar, so on and so forth.
Hello, my name is Paul Young.
Function, or zeta log.
My co-author Brett Tangadol, I'm pleased to offer you this video introduction to our paper on p-adic multiple zeta and log gamma functions.
Okay, that was really, we're going to walk out here with the detail, guys. That's a zeta function. We got to find the military guy out here talking to you. We need to find the zenith of this route. Well, what's out here, Sarge? Well, we got a cup of sand. What's in there? I don't know, sand. Go, you're not fucking ADP hard enough.
Which is to be published in the Journal of Number Theory. Multiple zeta functions were defined and studied by E.W. Barnes around 1900. And these are n-dimensional analogs of the Hurwitz zeta function.
So they are numerological bandwidths. Temperature at 27 million degrees, I think is what the sun is, and that's a yellow, well, depending on how, it'll go red giant, so it's whiter to yellow, eventually it'll get through there. But Kelvin is that temperature. It's a N number in K states, which is kinetic to a prime state that's involved with it. Very messy process. Again, let's take a walk on a beach and just analyze what happened as far as microbiology life in that cup of sand, or why this area is QNP relative to the equator. QNP has two different life organisms there that have radically different evolutionary standards and things that might be a gamma function. They have a lot of the same things. This one's a higher salt concept. That's an N number. And so it'll evolve differently, Brownian motion down the line for statistics. And you're going to watch him, here we go. You're going to watch him in calculus probability for Brownian motion and stuff like that. That's basically what we're doing. It's a drunkard walk problem. You send people out there. It's a flat plane or flat curve sphere of this panel of it. And again, we're just walking on it here, and it's got topology issues and things that can create a hidden variable. When did we put that on the zeta function? This Riemann sphere is a way that we... How do you make a sphere? Well, give me one of this rock right here. I'll cut it into a flat edge. I'll get a square edge. I'll make it as close to 90 as I can possibly get it, so I can have one flat edge, so I can make a measurement of a straight line to get a radial with a string, draw a ring around it. So I'm hitting two planes of it. Hopefully I have three flat plane surfaces. Otherwise, I'm starting to do, some olive-shaped system here, because even though it would be a circle, that circle has to be dimensionally 0.5, right, or 1/4. It's a two-dimensional thing here, even though the atoms of Sharpie pen on here matter, they don't matter. And that's like a gamma radiation. You can see how it matters, but it doesn't matter. If you had the eyeball skills, but to do it analytically like a machine, which is the only way you can be really sure of as far as statistics like this, you got to be Kayla Hergood here for sure inside of the system. Now, I don't know what she really does. She's just giving us a brief. She might be reading a teleprompter, but at the same time, I'm sure there's much more research that goes into that the memorization of that thing, to say it, maybe even potentially quit if it come to it. I don't know if it'll come to that. You get in some hacks about, well, anyways.
You take a single linear form in n
Simple linear form. Take a walk. Take a run.
And sum it as a
sprint it.
Series into complex variable
n. When you're emitting a number that is of sprint times, when the majority of people are walking through there, it does, just walking past that many air molecules creates a reaction that's almost gamma. It's a gravitational... The argument there is linear to the equation we said a second ago. Is that what... When you say mass is energy comparatively to energy is temperature, everything's ball waves. But here's a solid piece of something. And in a way, that gamma is that solidness that's stupid hard to explain, the bonds of certain elements. We know it's X. We know it's a line, this string that in a simulator could program that, certainly by mathematics. It doesn't need to be all computer.
You have to put the poles in manually in order to get a meromorphic function.
Sometimes people stuff, family or house, they can, if you have a house of X square footage, a 2-bedroom, 3-bath, or 2-bedroom, 2-bath, and you have 6 people in there, it's used to a zeta function of 2 parents and 2 kids or whatever it is. That's the multiple law of gamma function there. But when you are coming up with a different equation, are you separating the local gravity features away from Q and P? Because we know they're both the same thing in superposition, but we also know that they can't be. Well, this rock is this rock, but that rock is that rock.
functions.
Alright, so anyways, I hope that gives you a little insight.
That is not the
Catch you on the
analog
next
of
one.